and we bring metal to life.
To encourage leadership and help new members, we have a leadership team. We have multiple ways for members and parents to get updated, including Remind 101, emailing updates, our website, and even social media such as Twitter. We encourage gracious professionalism since it's a key part of FTC, and also we believe in it. We help other teams who are in need of assistance, and we even carry food for others. We reach out to the quiet people in our team by delegating jobs accordingly so they can bond with the other team members.
Building a robot is expensive. Therefore, we make sure to create a funding plan with ways to obtain money and a budget so we know how much we need. Then we make sure to keep track of all our spending in our engineering notebook. To earn money, we've gone to Barnes & Noble during their Mini Maker Fair. We've also decided to sell donuts once a month and have already submitted the paperwork. Of course, looking for sponsors and getting grants is also a main source of our income.
We used Creo to design our arm because it allowed us to manipulate the dimensions and simulate its functions. We saw how elements of our robot would fit together and how we could solve a problem by designing custom parts such as our hooks, arm, aluminum axles, and welded center steel frame. Because it's more practical to modify software rather than hardware, we built our robot first and designed our software around the robot. As talked about previously, we went through countless iterations and prototypes of our arm. Problems such as flipping over, unreliable hooks, and the arm not being strong enough were fixed. We plan on creating a ball scoring mechanism in the coming weeks. Our design is made of milled parts and laser cut pieces, which adds to the aesthetic appeal and functionality. The engineering centerpiece of our robot is the arm used for climbing, which utilizes hooks and chains. At first we used a linear actuator to adjust the arm's position, but evolved to sprockets to get a greater range of motion. Within the arm we have a gear driving the chain that contains custom-made aluminum adapters that hold the hooks. The hooks grab onto the rods as the chain spins, which pulls us up the ramp. CAD was important to our documentation since we could refer to previous designs and make adjustments.
Unlike other teams which use tanks, we decided to take the creative route and use an arm with hooks to pull us up the ramp. Creative by creating gaps between our wheels in order to both space our sprockets properly and to act as latches on the rods when going up the ramp. Our software is also creative. Because our drivetrain and arm's gear ratio were sometimes too fast when going up the ramp, we programmed a button that allows us to slow the motor speed, allowing us more control. To help us strategize, we scout each team to determine the robot's capabilities. Based on this information, we discuss the best plan of action with our alliance partners and delegate which robot should target which objectives. For autonomous, we made a program for both sides of the field. Each program makes our robot push our respective button and put the climbers in the basket. We have also established a way to climb up both ramps on either side of the field in case our alliance had basket scoring capabilities and could climb. If they couldn't climb, we try to stay clear from them by focusing on climbing up the ramp and preparing to hang for the whole duration of teleop.
Our members are always excited to spread the knowledge of FIRST. We held a summer camp to expose our fellow high schoolers to FIRST and teach them about robotics. We also extended our knowledge to the community by hosting a Cub Scout night. This exposed the young minds of tomorrow to basic robotics and FIRST. Recently, we attended ITSEC, where we learned from experienced engineers and reached out to possible mentors.